All right, everybody. So we've learned about covalent bonding. We looked at electronegativity difference, and then we were able to determine bonding, but what type of bond we have. So we're going to move on to a covalent bonding in particular. So how do we actually show this? Okay, so the key is how do we actually show covalent bonding? All right, and what we're going to do is do something called covalent Lewis structures, and they're not necessarily hard. But you have to follow some certain guidelines when it comes to this. So, important to know about your dot structures. So, first thing first is we're going to start with the Lewis dot structure of your atoms themselves. Okay. So again, we talked about how to find the valence electrons. So it's important you know how to find the valence electrons. Okay. You use the valence electrons in any way you need to do that. Okay. And what we're then going to do is pair up. Okay, your single dots. Okay, with other elements that also have single dots, and that's why I have this little joke here: single ready to mingle. Okay, if you ever been to they have singles parties where people go to meet, you know, to go dating, or they want to meet and find a date. They go to a singles party to match up with another person. So when we do this, you're going to pair up your single dots, single electrons into pairs. Okay, and those shared pairs, because they're shared, they're going to count for both atoms. All right, so that's really number two and number three are the most important part. You don't want to leave a structure with single dots hanging out. Okay, you want to make sure everybody's paired up, and once everybody's paired up, you should have the molecule correctly drawn. All right, just be sure that each molecule, each atom at this point, has at least an octet. Okay, so we want to get to that noble gas configuration with each element. Okay, and don't forget that hydrogen only wants two. All right, so let's just look at an example, simple example. Say you want to draw the Lewis structure for the compound HCl. Okay, so if I was to draw the two dot structures for H and Cl separately, I would have hydrogen with one dot. I'm going to make that red. You don't necessarily have to do this. Okay, and then I would have chlorine with 7 dots. Again, group 17 versus group 1. Okay, and I have a couple of options what I can do. Now, if you notice, you'll see a dot here, a single dot here, and a single dot here, and a single dot here. And those are the two dots you want to match up. Okay, so what we're going to do is we're going to go over here, and we're going to simply bring this element together with that element, and we're going to have those drawn together. So I would have H with a dot there, okay, and chlorine. So basically what I simply did was bring my elements together like that, okay? So basically what I would have, okay, is now this situation where you would have a shared pair, all right? So your shared pair of electrons is this bonding pair right here. So it's important to know that if you circle that and circle that and you create a little Venn diagram out of that, you don't have to do this. This pair in the middle is actually shared by both atoms. So you're going to think that the chlorine actually owns those 2 electrons, and so does the hydrogen. So now the chlorine has 8 valence, okay, by overlapping, and the hydrogen has 2 valence overlapping, okay, and that would be a correctly drawn dot structure. So that would be correct the way it's drawn. Again, you don't have to have those circles around them. It's just to show you that that's a shared pair. Okay, there's another way you can do this. This is really method number 1, and there's another way to show this. I kind of like method number 2 better, but not necessarily. It's also correct. So both are correct. So if you like the all dot method, then you can use that. If you like this method, even is different. What I try to do here is I take the 2 dots, okay, like that and like this, all right, and I would simply draw a line between them to connect them, and they get rid of the dots, okay, and then I'd end up with that kind of thing. So the line here represents the line would represent the bonding or the bond between the 2 elements. Now, something to really think about also on the side here is these electrons that you draw that are not involved in the bonding. Again, in both structures, you'll see these electrons here that are not involved. And they're not involved. They're called lone pairs or non-bonding electrons. Okay, so they're not involved. These are not involved in bonding. All right. Now, again, they complete the shell, but they're not involved in that bonding part, okay? And again, lastly, a line is going to equal a shared pair, okay? So anytime you have a line that's between two atoms, that's going to equal two dots, okay? Or shared pair. Okay, that's really important. And again, the shared pair counts for both atoms. So when you count this up, you're going to go 2, 4, 6, 8 for chlorine, and only 2 for hydrogen. All right, so it's really simple. You just have to simply move those together and mix the dots. All right, so we'll practice a little bit. So say you had NH3. Let's do a couple practice problems. Let's say I have NH3. Well, I can say when I have N. Let's look up N for a minute. N's going to have 5 dots. So I can go, okay, 1, 2, 3, 4, and 5. Okay. And I have an H that has 1 dot, and an H that has another dot, and an H has another dot, right? So I have 3 H's. So I'm reading the formula based on what I have here. Now, I can see that nitrogen has 3 dots, 3 lone dots, and each of the hydrogen has 1 dot apiece. So I can connect them to each dot, right? So this dot could go there, that dot could go there, and that dot could go there. So you could simply have the N, against there's your lone pair we talked about. And now the H, you can move the H to the side here, an H to the side there, and an H to the side there, right? And I would form that kind of structure. You know, and again, if you wanted to make these X's to show that these are X's, then you could have an X there, an X there, and an X there, and those would be your 8 dots. And you can see the nitrogen around here, that has 8 dots. Each hydrogen around here has 2 dots. Okay, so that would be a correctly written structure. Okay, again, you don't need the circles, so you can always draw this. You could have drawn this as N like this, like this, like this, like that, and then H, and H, and H. Okay, so that would be fine. This would be written fine like that. Okay, another way you could do that is see the lines that you've drawn. You've drawn a line from the hydrogen to the single dot, from the hydrogen to the single dot, from the hydrogen single dot. You could have simply just leave the N alone, line to a hydrogen, line to the hydrogen, line to the hydrogen. Okay? And again, I would leave it in the shape where those single dots are. This is called a central atom, and a central atom is going to keep the bonds coming off the sides and the bottom for a reason. So that, of course, would be also a correctly drawn atom. Okay, again, what kind of bonds are here? Well, we have an NH bond, so that's going to be polar, right? Polar, because N has a higher electronegativity than H. That's going to be polar bonds. All right, in CO2, we have something a little more interesting, right? We have carbon that would have 4 dots, right? 4 dots, okay? And then we have a little oxygens. Now, what we could try to do is I don't know where to put them. We can put them anywhere. I'm going to put one on one side and just one on the other. Again, you have 6 dots, so 1, 2, 3, 4, 5, and 6. And maybe 1, 2, 3, 4, 5, and 6. And you kind of have a singles party gone wild here with this one. So again, you're going to have to match everything up so that you don't have any leftover single dots. So again, sometimes it's trial area. You got to work on it a little bit. So oxygen has 2 single dots, and this oxygen has 2 single dots, and carbon has 4 single dots. So if we start matching things up, we can say, okay, maybe this guy can go with that guy, right? This guy can go with that guy. This guy can go with that guy, and maybe this guy can go with that guy. So when we put it together, we can actually form C in the middle. We have 2 dots, 2 dots, 2 dots, 2 dots. So 2 dots, 2 dots, 2 dots, 2 dots in between. So 4 dots in between these 2 elements with an oxygen. And again, now oxygen still has those lone pairs on it. And you have the same thing on the other side. So you'd have C, C with 2 dots, and 2 dots, and 2 dots. All right. Now, since 2 dots make a line, we can always look at the lines you've drawn here and say, okay, carbon is going to have 2 dots. It's going to have like that. And this is going to have like that. So it's one or the other. Both of these are right. Now, again, do we have octets? Let's take a look that we do. And if we took let's just look around carbon. Carbon around it has 8 valence electrons. There it is. And this oxygen is sharing 2 pairs of electrons. 2 pairs of electrons. Okay? That is called a double bond. for obvious reasons. Okay, and a double bond has 4 pairs. Sorry, 2 pairs. 2 pairs. Okay, so that's going to be really important on that. Okay, and last but not least, we can do CH4. Again, C is going to have 4 dots. Okay, and again, H is only have 1 dot. So you could probably say, okay, there's going to be H here, put an H here, and an H here, and an H here around them, right? And then we can just connect them. Okay, but just understand that you're not going. That's nothing. So that you're not going to ever draw dots and lines. It's either dots or lines, or dots or lines. It's not dots and lines. Important to know. All right. So if I write this, I would have dot dot for the hydrogen, dot and dot for hydrogen, dot and that hydrogen, dot and that for that hydrogen. Okay, and if I want to go and put them together for lines, I would have 1, 2, 3, 4. Notice I am following the dot configuration around that atom. I'm keeping those dots around it, keeping those dots around it. Okay, again, this would be a polar bond. 2 different nonmetals. Again, this polar bond. 2 different nonmetals. Okay, so really important. So there's 3 good examples of dot structures. Yes, you have to be good at this. So we're going to practice even more. And on the first worksheet, there's a practice problem. All right, so go back over this if you need to. Ask in class. Don't be afraid to make mistakes. Use a pencil. And then you got this thing. You got it. All good.